Forget the Bahamas. Forget Mars. If you crave a truly extreme vacation, pack your heat shield and grab your ice skates. We're blasting off to Mercury, the solar system's ultimate roller coaster of fire and ice. On this tiny titan, days sizzle at 430 degrees Celsius, hot enough to melt lead. But as the sun dips, the Mercury, pun intended, plummets, plunging cratered landscapes into a frigid minus 180 degrees Celsius nightmare. This isn't just hot and cold. This is a cosmic tug-of-war where ice hides in eternal shadows and volcanoes whisper of ancient oceans. Imagine a world where the sunrise turns lead to liquid and the sunset freezes your breath, where fire rains on sunlit plains and ice hides in eternal craters. This is no sci-fi fever dream, but the captivating reality of Mercury, the smallest and closest planet to our blazing Sunday. Here, temperature swings from inferno to icebox define every landscape, painting a story of a planet caught in a cosmic tug-of-war. Mercury's scorching side basks in the sun's unrelenting gaze, temperatures soaring to a bone-melting 430 degrees Celsius. This fiery embrace molds its rugged surface, carving craters deeper than skyscrapers and painting the desolate plains with hues of burnt sienna. Here, even sunlight dances at the edge of destruction, evaporating anything daring to touch the ground. Yet, as the sun dips below the horizon, a dramatic shift unveils the other face of Mercury. Nightfall plunges the planet into chilling darkness, temperatures plummeting to a teeth-chattering minus 180 degrees Celsius. In this perpetual shadow, craters become icy tombs, trapping water vapor like forgotten diamonds, whispering of a time when Mercury may have boasted oceans and a life-giving atmosphere. This dance of fire and ice, this waltz of extremes, defines the very essence of Mercury. But what forces orchestrate this cosmic spectacle? Why does a world bathing in sunlight shiver during the night? The answer lies in a delicate interplay of proximity, rotation, and a missing ingredient, atmosphere. Mercury's tight orbit around the sun, a mere 36 million miles away, subjects it to an unending solar assault. Unlike Earth, shielded by a protective blanket of gases, Mercury absorbs every photon of sunlight, transforming its sun-facing side into a furnace. But with no atmosphere to trap this heat, the night side becomes a cosmic freezer, radiating warmth back into the vast emptiness of space. This absence of an atmosphere fuels another fascinating consequence: Mercury's slow, unpredictable rotation. Unlike Earth's smooth 24-hour day, Mercury takes 59 Earth days to complete a single rotation. This sluggish spin means a crater bathed in sunlight one moment can find itself plunged into icy darkness the next, creating dramatic temperature swings even within its day-night cycle. Unveiling these temperature extremes is no easy feat. Scientists rely on ingenious tools like temperature-sensitive instruments aboard spacecraft and radio waves bouncing off the surface to paint a picture of Mercury's thermal tapestry. These measurements reveal not just scorching days and frigid nights, but intricate patterns of heat distribution, shedding light on the planet's geological history and potential hidden oases. But the temperature story of Mercury is more than just numbers on a screen. It's a window into a distant past, a tale of volcanic eruptions and evaporated oceans. It's a whisper of ice in the shadows, a hint of potential life clinging to the fringes of existence. It's a cosmic mystery waiting to be solved, an invitation to explore the most extreme environment within our solar system. So, are you ready to delve deeper to get more knowledge about Mercury? Imagine standing on the sunlit side of Mercury. The landscape stretches out before you, a desolate expanse of cratered plains painted in shades of scorched umber and fiery orange. The sun hangs large in the sky, its fierce light magnified by the lack of atmosphere. You wouldn't last a second unprotected. Temperatures here soar to a staggering 430 degrees Celsius, hot enough to melt lead and vaporize most metals. Even rocks crackle and hiss under this relentless solar bombardment. This inferno isn't just skin deep. The sun's rays penetrate deep into Mercury's surface, baking the planet from the inside out. Over billions of years, this thermal torture has sculpted the landscape, carving craters deeper than skyscrapers and leaving behind a network of canyons and ridges etched by thermal expansion. Imagine landscapes warped by heat, mountains buckling under immense thermal stress, and evidence of ancient lava flows frozen in time. But while the surface bakes, a fascinating interplay unfolds beneath. Scientists believe that vast deposits of ice lurk within permanently shadowed crater floors, shielded from the sun's direct gaze. These cold traps act like time capsules, preserving remnants of a potentially wetter past, when Mercury may have boasted oceans and a more hospitable climate. Could these icy oases harbor microbial life, clinging to existence in the fringes of this searing inferno? Living on the sunlit side of Mercury, even for the most heat-resistant microbes, would be a constant battle for survival. Not only must they endure the scorching temperatures, but they also face a barrage of solar radiation, cosmic rays, and micrometeoroid impacts. Only the toughest extremophiles, organisms thriving in the most extreme environments, could even contemplate calling this fiery furnace home. Yet, the harshness of the sunlit side might hold clues to Mercury's past. Minerals baked by the sun's heat provide insights into the planet's composition and early volcanic activity. Studying these heat-forged signatures helps scientists piece together the puzzle of Mercury's evolution, from a molten ball of rock to the scorched world we see today. So, while the sunlit side may seem desolate and unforgiving, it's a vital piece of the Mercury puzzle. It's a canvas painted by fire, its scars whispering tales of ancient oceans and volcanic fury. It's a testament to the sun's immense power and a reminder of the incredible diversity of environments in our solar system. As the sun dips below the horizon on Mercury, a dramatic shift transforms the scorching landscape. No longer are we bathed in the inferno's gaze. Instead, we find ourselves plunged into the perpetual shadow of craters that act as cosmic refrigerators. Here, temperatures plummet to a jaw-dropping -180 degrees Celsius, colder than the Antarctic winter and enough to make your breath crystallize. The once scorched plains become cloaked in frost, painting a surreal portrait of ice amidst a fiery world. But this isn't just a frozen wasteland. Within these craters, shielded from the sun's relentless heat, lies a hidden wonder, vast deposits of water ice. Radar echoes bouncing off the surface unveil these icy oases, remnants of a time when Mercury may have boasted oceans and a more hospitable climate. Imagine stepping into a crater, not to find molten rock, but a glistening expanse of ice, a frozen testament to a watery past. This ice isn't just a geological curiosity, it's a beacon of hope for the possibility of life on Mercury. The cold, dark environment may seem harsh, but some extremophiles, microbes adapted to life in the most extreme conditions, could potentially thrive in these icy havens. Imagine microscopic life forms huddled within the ice, fueled by geothermal energy and shielded from the sun's harmful radiation. Could these hidden oases be harboring pockets of life, clinging to the last vestiges of liquid water on this scorched world? Living on the shadow side, however, poses unique challenges. The eternal darkness presents difficulties in finding energy sources, whether it's sunlight for photosynthesis or geothermal vents for chemosynthesis. Additionally, the constant freeze-thaw cycle could put immense stress on any organisms, requiring extraordinary adaptations to survive. Studying these icy oases is no easy feat. Scientists rely on radar data, spacecraft observations, and sophisticated computer models to piece together the picture of what lies hidden in these eternal shadows. Each new discovery, each glimpse of reflective ice or hint of organic molecules, fuels the fire of curiosity and ignites the search for potential life beyond Earth. The frigid shadow side of Mercury isn't just a frozen desert, it's a tantalizing possibility of a hidden biosphere, a reminder that life might find ingenious ways to adapt and thrive even in the most challenging environments. It's a testament to the enduring power of water, even in the face of unimaginable heat and darkness.So, while the dayside scorches and the nights freeze, Mercury whispers a hidden story of ice and resilience. From the sunlit inferno to the frigid shadows, Mercury is a symphony of extremes, a world dancing on the knife's edge of existence. Its temperature tapestry tells a captivating story of a fiery past, a possibly watery present, and the tenacious grip of life in the face of unimaginable harshness. As we unravel the secrets hidden within its craters and ice caps, Mercury ceases to be a mere celestial speck and emerges as a cosmic laboratory, challenging our perceptions of what life can endure and where it might thrive. This scorched wonderland, bathed in fire and cloaked in ice, becomes not just a destination for exploration, but a testament to the universe's boundless potential for diversity and the humbling realization that we, on Earth, might not be alone in the grand cosmic stage. So, let us continue to listen to the whispers of Mercury's temperature waltz, for within its extremes lies a universe of knowledge waiting to be unveiled.